What number are you guys on?
Two.
3?
What is this?
Yeah.
You try a couple more just for practice.
There's a little bit of
If you get done early, you can pick another one to try. You might see some things like this, like your request, more practice instead. You're fine.
Oh yeah, I for sure. We're converting the
To get like
Did you get 164.997 grams? How'd you get that? Well, I didn't know
What shortcut? I think that you guys are actually doing well the way you are. It would confuse you. Yeah, it's a little bit more advanced, and once you guys get better, like maybe the next week, I'll tell you one shortcut. It's only for like one style problem. It's not really useful everywhere, and I just don't want you to confuse yourself. Okay.
Did you get 24?
Oh, you did that too.
I think you did. Alex is already. Except
All right, Ian, you are coming back to me in 3. Thank you. 2, 1. Okay, I want to know answers and process. Okay. So looking at 2, we had aluminum nitrate. Give me thumbs up if you had aluminum nitrate's formula right. Al parentheses NO2 parentheses 3. You're probably getting better at nomenclature. Keep practicing, okay? So you have to take your formula units. So point to the mole map where we are, okay? Where's the mole map where we are right now? To upper right, right? So we're visualizing it. Upper right. We're going where? Here to moles, and then swoosh to over to grams. What was the aluminum nitrate or nitrite's formula mass?
I got
165.
165 point what?
01.
003, something like that. Okay. So I didn't calculate, just working with your numbers. So as you went across and you divided and you multiplied by 165, what was the total mass? 0.244?
I got 24.4.
Oh, maybe, okay. 24.4.
I believe.
24.4.
Yeah.
Okay. So consensus majority rule says what?
24.4.
24.4 grams.
No, there's only.
Okay, but if it was 4 or 5, we might round it up to 0.5. But regardless, we got our problem. We're good. Next step, iron has a what charge in this case? 3. Carbonate has a 2 crisscrossing charges. Iron 2, carbonate parentheses 3. This was a single step because you were just going from moles to formula units, right? Yeah. Moles to formula units. Okay. So single step. So we went from where? Where on our map? Point to it on your map. From mole to formula units. Okay. Keep that visualized. What's your answer? Times 10 to the 23rd formula units of iron 3 carbonate. Next, point to where we are on the map. Bottom, so molar volume. We're going from liters to moles using 22.4, and then moles to molecules to go to molecules. Okay? Answer? Answer?
7.95 times
10 to the 22nd. Molecules. Apostrophe C is molecules. Okie dokie. You know your mole map? Do you know it? You got it visualized? Okay, the more you practice on problem set 10, the better you're going to get, okay? So what we're going to do today is we're going to go through, there was a simulation we didn't quite get to yesterday. We're going to do that maybe in about 30 minutes. So we're actually going to finish up everything from problem set 10, which as you read, maybe you read ahead. Did you guys see the style of questions that were coming next?
Yeah.
You see it said empirical formula, molecular formula, that's it, that's the last bit, okay? But it's using the same concept, so we're just applying it in a slightly different manner. So go ahead and pull up the lecture notes that you had started with a couple days ago. We're going to reference those shortly, but not immediately. So we're going to reference those shortly, but not immediately. Okay, so this is your bread and butter for today. Actually, not this part. This is intro. The bread and butter is going to come in a second. But as you read over it, I will explain it. So read over it first. Read over this first, and then we will explain. You definitely should write something down. Good question. Definitely write something down. No? Yes, I'm going to chemistry one of that titration. It's a titration process. I'm sorry, I ruined that for you. Alright, so you are writing down a little bit here for me, and then we're moving ahead. So, we have been working with empirical formulas this entire time. We have been. Because every time we had a ratio that we could reduce, what did we do? We reduced it. So you didn't know, but I had mentioned it one time and I kind of just let it go. But anytime we reduced an ionic compound from like a 2-to-2 ratio down to a 1-to-1, we were writing the empirical formula. So the definition of empirical formula is the simplest ratio, or the smallest full number ratio, within a compound. Now, we always do this for ionic. Always. But whenever we wrote out, like, let's say dinitrogen tetroxide, write that down for me, dinitrogen tetroxide, or tetraoxide. What's the formula for that? N2O4. This was molecular, right? Molecular meaning covalent. Did I tell you guys to reduce this one? No. So we did not reduce, because that was the formula of the dinitrogen tetraoxide. It said so in the prefixes. So this right here, being molecular, is the, well, not only this, but this is the compound that we're not reducing, and we're leaving it in this formula standpoint. This is called a molecular formula. So if I did want you to write the empirical formula for molecular, I would say take it to the simplest ratio just for clarification, like that's what the empirical formula is. So for this example, hydrogen peroxide, what would the empirical formula be here? HO, so H1O1, because we would take the 2's, divide by 2 to make them both reduce down to 1's. What would the empirical formula be for glucose? I'm going to put C1, H2O1, because what did I do to all of these subscripts? I divided them all by 6, which is their greatest common factor. Greatest common factor? Greatest common factor. I've got my math done too. So I'm dividing by my greatest common factor. I'm really reducing them to the simplest ratio. So the 2 to 1 ratio, the 1 to 1 ratio, those are the empirical formulas. But these over here, non-reduced, are the molecular formulas. Good. So the reason that we never actually reduced a covalent molecule's formula is because if the covalent molecular formula is dinitrogen tetroxide, that's the true formula. So we do not want to actually reduce that because then we'd be modifying the molecular shape. So we want to keep it in respect where it is. But it's still a whole number ratio. But it's just not the most reduced one. So it's a whole number multiple of the EF. So going back to this example up here, if I take my empirical formula, C1H2O1, what am I multiplying all the subscripts by to make the molecular formula? So I'd technically be multiplying all these subscripts by 6. That's 6, that's 12, that's 6. And that's going to be my molecular formula. So that's why it says it's a whole number multiple. Thumbs up when you've got what you've got to get. So I want you guys to, on the next slide, to identify the ones that are empirical versus molecular. Okay, so look up here, number 1, empirical or molecular? So I guess the thought is, can you reduce it? Yes. How can you reduce the 1 further? So can you reduce it? No. So is it in the simplest ratio? Yes. So it's the, hold on, is it in the simplest ratio? Yes, so then it's the empirical formula. Okay? Is this in its simplest ratio? So it's the molecular formula. Is this in its simplest ratio? So it's the, next? So is it empirical, yay or nay? Yes, because the 1 and the 1 here are in their simplest forms. So this would, and this is also an empirical formula. That was so loud. Okay, this is an empirical formula because it's ionic. So whenever there's a 1, is it? When there's a 1 in yes, then it's empirical because you can't reduce anymore. Yeah.
So if there's like the second number, if there's like more than 1, then it's molecular?
No, not necessarily, because it, like, for example, this one there's more than 1, this one's more there's more than 1, but this was a 1. So if there's a 1 in it, you are at your simplest ratio. Okay. So those are just some examples for identification purposes, but I think you guys got the point. Empirical is simplest, molecular is more. Empirical is easy, molecular is more. Things are like that. All right, so this is the bread and butter, and we're going to use these steps. So I'm going to be quiet. We're going to use these steps to solve all of our problems. So read, and then I'll tell you what I would write, but read first. So if you want a cheat sheet for the steps on how to solve, this is your cheat sheet right here. So if I read those rules, I would say, okay, get to moles. Very first steps. Whatever I've got, I can give you grams, or I can give you percents, or I can give you formula units. Get to moles. Next step, look at all the moles you got. Choose the smallest. Divide all of them by the smallest moles. When I am doing that process of dividing by the smallest moles, I am getting a ratio. That's what I'm actually doing, is I'm getting that ratio. And that ratio that we had been describing earlier, we were looking at it, but we never said the word. Where was the ratio appearing in the formula? In the subscripts, right? It was like telling you one of these and 12 of these and one of these. So that's the subscript. So the number you got when you divided those moles by the smallest moles is the subscript. This is the simplest I can make that. So one note is occasionally when we divide, we don't get a whole number. So I've never seen like carbon 1.3, hydrogen 2.7. Like you've never seen subscripts that are decimals, right? So we have to sometimes modify these subscript forms to get them to a whole ratio. And that's what the lowest part down here is, where it says if they're roundable, you can round them to the nearest whole number. They're only roundable if they're lower than 0.15 or higher than 0.85. Like it could be 1.15. I'd round that down to 1. Or it could be 2.85 and I'd round that up to 3. But any of these other situations, we have to modify the subscript just to get the ratio right. So here's how you modify. If you have a 0.5 ending, you just multiply by 2. Goodness gracious. Sorry, this guy's messing up. Okay. If you get a 0.5 number on the end, you multiply by 2 to get to a full number or to a roundable number. If you have 0.3, you just multiply all, and this is going to be multiplied all subscripts by this. When you multiply 1, you screw up the ratio. So if you had 3 elements you were finding the moles of, you're going to do that for all 3 of the elements. So if it's 0.3, you times by 0.3, times by 3. If it's 0.6-ish, you can times by 3 and it'll get you close to a whole number. And if it's 0.4 or 0.8, you'd multiply by 2.5 to get close to a whole number. We will see this maybe every other question or close to maybe 1 in 3 questions. We won't see it all the time, but it's going to happen. Thumbs up when you're good here. But this is your bread and butter right here. This is what we're going to work with. All right, most of us look pretty good. I can come back to the rounding thing when we get to that point. Okay, so what happens is occasionally, okay, little guy, you got this. Maybe the board's just being goofy. Okay, I think I skipped something. Nope, okay. So we have some samples that we're going to represent in percents, which is what we talked about yesterday. So I can't really convert a percent to a mole because I don't have that on my mole map, right? It's not there. So what I usually tell people to do is just assume that you have a 100 gram sample, and then those percents immediately turn to what? Grams, because like 94.1% of 100 is 94.1 grams. And 20.2% of 100 grams is 20.2 grams. And we can take grams to moles, right? Where are we at on our mole map if we're in grams? Middle, and we just do one step and go to moles, okay? So here we go. Take out your calculator, get your periodic table, we're rolling. 94.1 grams of oxygen. What's the molar mass of oxygen? 16 grams of oxygen, 1 mole of oxygen. Calculate. What? I'm just going to stop there. It's good. All right, so 5.88 and some change is our moles of oxygen. So now I'm going to do the same thing, but 5.9 what? What unit goes here? Grams of hydrogen. I'm going to convert that to moles. So 1.008 grams of hydrogen is equivalent to 1 mole of hydrogen, and that should be about 5. Say that again. Did you divide by 1.008? It's too low. 5.8 something. 853 moles of hydrogen. Okay, look at our steps. Which step have we just done? We've gotten the moles. We've done step 1. We took our percents. We said, okay, assume a 100 gram sample because I can't work with percents. Now go to moles. We got step 1 done. So guys, what's the next step? So divide by the lowest number of moles. Who's got the lowest moles? Hydrogen or oxygen? Okay, so I'm going to divide both of these by 5.853. Well, what's this one going to be? 1 because it's representing itself. When I divide this by 5.853 moles, it's still approximately 1, right? What is it exactly?
1.0047.
So 1.004, that's all I really need to hear, right? That's roundable, right? We're going to round down to 1. So what's the ratio, meaning the subscripts? Well, we've got H and O, right? So O1H1 is actually OH with a charge, and I'll tell you this is charged, but it doesn't matter. Who's that? Hydroxide, right? And that's the empirical formula of hydroxide. Okay, we've only done one example, so we're going to have to let it sink in for a little bit. So let's go ahead and do another example. Okay, so I want you guys to start the same process, but do it for B. Yeah. I just did it because I wanted to show you guys this hydroxide. Yep. Don't worry about the charge there. Do the same process in these steps. Get to moles, divide by moles, and the numbers of subscript line for B.
I mean, 5 days.
I didn't, don't worry. I just was OH by itself. Okay. Okay, so then you're going to put
79.8. I never explained my Okay. And then next to it, you put 1 more. Like those numbers more.
Oh, wait, never mind. I was reading. Excuse me? Oh, periodic table molar mass.
So then you put 1 okay. And then under? Yeah.
Right, take 30 more seconds.
A Do that first one. So 12.0.
Grant, what's this number? Moles of carbon.
6.6.
Anthony, what's the moles of hydrogen? 20. My bad. I'm writing blind. That's a 2, guys. It's a 2. So 20.0.
So wait, you don't do like the 0.01?
It is 12.01. I just was trying to scratch it out without totally scratching out the whole word. So we got moles of carbon and moles of hydrogen. Are those our subscripts, guys? No. So what's my next step? Divide everything by what? 6.64. Divide by 6.64. This is what? 1, because you're dividing by itself. This is what's this exactly? Okay, so definitely roundable, right? So we're close enough to 3. So what's the formula? C1H3. So we would just write that as CH3. There you go. And that's just our 1 for carbon, and our hydrogen came to a 3, so we put the subscript here and here with alongside of it. Give me a double thumbs up if you can do these. Okay, so I have given you percents, which just made us go to grams, right? Do I have to give you a percent, or can I technically give you something else? I could get you something else, right? I could actually, instead of saying assume 100 grams, I could just be like, hey, here's the grams, right? So here's the grams. Are these on your paper? This is on your paper, right? Go ahead and try C. Hallie's your hand up.
Oh no. So we're trying to find basically one So this is the total sample, this 140 grams. We have 96 grams of carbon, so we need 20 grams. I would first subtract 91. Wait, what are you doing? So there are 24 grams in carbon. No, yeah, because. Oh wait, no, yeah. Okay, so then we basically do negative ones.
Yeah, but you just want to.
But if we have that, we have to do that
All right. If somebody next to you needs to focus, don't talk to them. And then I'm going to start on the board, but blind. So don't look. It's about to be. In just 1 second, yep. I can't do this blind very well. I'm going to move ahead though, so you're just taking the lowest moles, this is the lower one, so you're dividing by itself, and you're dividing it down here as well. Anna, what's this one? 7? Carbon. 9. Well, what was the hydrogen? All right, guys, you should have been able to get to your moles fairly quickly. We've been doing this for a week, not quite a week, but decent. So you got your isolated your grams from your other grams. So we had carbon and hydrogen separately. You take your grams to moles using molar mass. Grams to moles using molar mass. So we've all made it through step what?
1.
Yeah, it's just step 1, right? So, Vanessa, what do I do next? I like to write down what you were saying. Divided that by 7.99. Good. So this one, everybody, think hard. 1. And this one? Approximate. What's the number? 3.1. So, all right, 2.97. So then you rounded to 3. So these are your subscripts, and what's the formula? CH3 again. So I gave you a new scenario, but the ending empirical formula was the same. Yeah.
I did something different.
Okay.
I found the percentages,
And then you went.
and then, so like, I did 96 over 120 and 24 over 120. and got 80/20, and then,
You assumed a 100-gram sample. What'd you do after that?
well, that would be 100% of the 120. And then, from there,
To 80% to what?
and then I divided 80 by the mass of carbon, 80% by the mass of carbon, got 6.66.
So basically what you're doing, and this some of you guys may have approached it this way as well, you took winter percent, and then you assumed, you didn't write it down, but you actually assumed on 100-gram samples, so then you said 80 grams. You divided it by 12.01 for the mass of carbon, and you got to a ratio, and then your 20 grams of hydrogen, you divided by its mass, you got to a ratio. The ratio is the same ratio, it's just not the same numbers. So you could do it that way, but I think it's an extra step because you're calculating percent when you could literally just take grams to moles here. But it still will work. Yeah.
Not round, like when we get to the mole, can we not round that to the 6?
I don't round. This is not your final answer. The ratios are your final answer. Okay, so if you guys feel good about that, then we're going to be great. So we're going to move on to another one that's similar to this, but we might not do that one yet. Okay, so we know the empirical formula. We know how to get that. Now we're going to find the molecular formula. It's not really that much more. It's literally one extra step that you do at the very end of the problem. So let's write down what's on the board first, okay? Write down what's on the board first. So you'll notice that you are over here in pink or purple. You're doing exactly, we're in the molecular formula problem, you're doing everything exactly the same as empirical. Except for at the end, you must get a multiplier. Remember, the molecular formula is a multiple of the empirical formula. So that's why we have to get a multiplier. So this is how you get the multiplier. This N is the multiplier. You guys okay?
Yeah, it's just asking for the multiple.
So 1 second, okay? So how do you get the multiplier? You will be given in the problem the compound molecular mass. Or you'll just be given the mass in general. That's the bigger number. So the bigger number goes on top. What you would have achieved through the empirical formula process was a formula. So for the last example we just did, our empirical formula was CH3. How would you find the molar mass of this empirical formula? Look at your table, add it up. So you'd say C plus 3 H's is like 15-ish. So this is going to be the smaller number. So when you divide a big number by a small number, you get a hopefully an integer, hopefully. So a number that's not like a decimal. It'll be, you know, like 2 or 4 or 6, and that will be the number that you serve as your multiplier. But then what do you do with your multiplier? You actually take the empirical formula you just got, and you distribute the multiplier in to the subscripts you just achieved. And that's where we apply our multiplier. Evan.
So if it's not all numbers, should we follow the math?
Not the multiplication side of it. It should be really close to a whole number. It'll be like 2.09. Like, it'll be close enough to round. If it's not, then go back and check your work, because something's wrong. Yeah.
So for the final formula, you can just leave the multiplier on the outside.
No, actually distribute it in so that I can see the new formula. And we will distribute. Okay? It's simple. Okay. We're going to do a problem together. Almost there, almost there. What's next on your sheet?
Example.
So the molecular formula tables. I'm only gonna do like 2 of these. Let's do 2. For 2. So I'm ignoring these for a second. Going down to this one. It says the empirical formula. Oh man, I've already given you the empirical formula. For, look at me, eyes on the board. Thank you. So you've already gotten the empirical formula. And then it says the molar mass of the compound is 179 grams per mole. So you have the empirical formula, you have this. How do I find the molecular formula? That's my first step. Find the, say, hold on, it's not, so we've already, this is the step to find the EF. We've already got it. We're done with this. I need to find the molecular formula. We need to find the what? Multiplier. Okay, so how do I find the multiplier?
Keep the molar mass on top.
Put the molar mass of this thing, right? Put the molar mass of the compound, which was given to me, 179 grams per mole, on top. And then what are we dividing by? This compound mass. So let's go find this compound's mass. 2 times what? 12.01. Okay, plus 4 times plus 6 or 7, whatever, good. So 50, 60-ish grams per mole. Okay, this is the empirical formula mass. This is our simplest formula's mass. What do I do with this number? Put it down here. So I think you guys can do that in your head. What's about 180 divided by 60? 3. So our, or 2.9 and some change, but yet again we would convert that or yield 3 for that. So this is our multiplier. So what do I do with my multiplier? Distribute. Good. So H4S. Put it back here. And then what's my new formula? C6H12S3. And this is our molecular formula. Look through it again. Just rationalize the steps we took. And we're going to move on to the next example. What made this part easier for you? I already gave you the empirical formula, right? I will not continually do that, no. Speaking of, look at the next one. Okay? So just as a note, I will sometimes abbreviate this up here as like N is equal to molecular formula mass divided by empirical formula mass. And that would be kind of my abbreviation for that. All right, so you guys have number 3 on your paper. Notice, do I give you the empirical formula?
No.
So what do you need to do first? Find it. Go first. Find the empirical. You wrote all in the space. You guys should use paper. It matters to you. You guys are doing great. Fantastic. I always loved it when my teachers told me I was doing great.
Yeah, thank you.
I mean, you don't have to say that for you.
Mom did that. Anything on the reading blah 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 blah.
Let me catch up with you guys. I gotta catch up. You guys are fast. I do. Okay. No, you did. Yeah.
There's a 0.25.
Where's your 2.25 at?
After I found all the masses and I divided by those.
If it's 0.25, you're gonna get it to a whole number. You multiply by 4. I don't know if that's the case though, so hold on. It is. I can't. I have a lot of questions in my brain. I don't remember which does what.
Oh, multiply by 4, multiply by 4. Just
All of them multiply by 4.
Oh, okay. Boom.
Yeah, I got 2.5.
Oh, 2.5. I
Yeah,
said
that's what
point. I thought you said 0.25. 2.5. How do you round this
It
up?
can be 2.5.
Huh?
It can be 2.5.
It cannot be 2.5.
It says multiply by 4.
Great. Eyes up here. You should at least probably gone to the close to the ratios. So as you get to moles, 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 you divide by moles, moles, moles. You get 1, 1, hit 2.5. So you cannot have a decimal as a subscript. So what do we have to do? Multiply by 2. And did we just multiply this one by 2? No, we multiply all of them by 2 to adjust the ratio equivalent in the same way for each one, okay? So, sorry Cam, I thought you said 0.25. So this one's multiplied by 2, and this one's multiplied by 2, and this one's multiplied by 2. So what's the subscript for K? The subscript for K is 2. The subscript for sulfur is 1 times 2 is 2. Just making sure we're good here. And then the subscript for oxygen would be 5. So the empirical formula is what? K2S2O5. K2S2O5. So we're still not done. EF is K2S2O5. All right. So what do I do with that random mass over there?
What about the total mass?
So that's getting our multiplier. We take the total mass and we do divided by the what?
The mass of the compound.
The mass of the empirical formula of that compound. So 859. So we're taking our molecular mass, which is our molecular formula mass, and we're dividing it by, what's the mass of this? 202?
Oh, it's 222.
22. So the empirical formula mass is about 222. Did we just add blah, 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 blah up? Okay. So this is the empirical formula mass that I'm dividing by. It's always big number over small number. What's our multiplier? What is it? 3.86. Is this in the realm of rounding?
Yes.
So we're rounding that up to 4. So the new formula
So good.
And then you got
All right, say DJ Khaled if you're done. No one said it.
I said it.
Thank you. Alright. So, listen. Hush. Hush, hush, hush. You guys seem like you did pretty well. Am I assuming that?
Yes.
So I should not assume that.
No, you should.
So if you did pretty well, am I correct in my assumption?
Yes.
Okay, because that helps me decide what more we're doing. If you need more problems, I can do more problems with you guys. Because you feel like that's what I'm getting to, but I needed to get feedback from the class. So what you'll notice is on the bottom here, do you see that they're empirical and molecular formula practice? Yes or no?
Yes.
Yes. Okay, so what I would do, and I'm going to ask for you guys to do 2 of these. What I would like for you to do is, there's one with a hydrate. There it is. Number 5. Do you see number 5 under the determine empirical formula? So this one, I want you to do that one. I just want you to do both number 5s, and then you guys can start your problem set. Do both number 5s, and you can start your problem set. Go. That means you have 27 minutes in class to get most of your problem set I will erase it right now.
the way you said it.
So here's my rule. Ready? Listen as you begin. I want to see both of these 5s done, and then if you wish, you can work with someone on your problem set at a lab station, but I need to see both of these number 5s done first. Okay? Can you do it first? 1 second.
Okay, so that's right now.
Yeah. After you get done, I'll turn my music on. Oh, gosh, it's hard life.